This is a lecture for section 7.4, MAC 2233, Applied Calculus. So in this section, we're going to be talking about the fundamental theorem of calculus. And basically, it says that the integral of f of x dx from a to b is just equal to the integral of the function fb minus f of a. In other words, whatever the function is of f of x dx, the integral of that, we just evaluate it from b. We subtract the value of a from the value of b for the particular function. So the next rule states that the integral of k times f of x dx from a to b is just equal to the constant times the integral of the function from a to b. So we can take out the constant and then evaluate the function and then put the constant back in. The next rule is the sum or difference, and so the integral of f of x plus or minus g of x dx from a to b is just equal to the integral of f of x dx from a to b plus or minus the integral of g of x dx from a to b. So we can separate those and then evaluate them. The next rule states that the integral of f of x dx from a to a, in other words, there's no change in the endpoints, if you will. It's just equal to 0. Then the next one states that the integral of f of x dx from a to b can be equal to the integral of f of x dx from a to c plus the integral of f of x dx from c to b. And so if I have an interval from a to b, then somewhere in here lies c, right? So if you were to think of a number line, this is a, this would be b, then c would be somewhere between a and b, not necessarily the midpoint, but just somewhere in that interval. And of course c would be a real number. And then the next rule is the integral of f of x dx from a to b is equivalent to negative integral of f of x dx from b to a. So if you switched the values for the definite integral, then it just becomes a negative value. So let's look at number 31. Now number 31, let's say I'm going to try to find this one right here. I can get it to work. And so the function is 2x minus 14. And so you can see here that the function crosses the x-axis at when x is equal to 7. So since we're going from 6 to 10, there's a portion of this integral that's below the x-axis. And so when we do this one of the things that we want to do is we want to find out, since it's telling us to go from the function to the x, the graph is going to cross the x-axis when x is equal to 7. I just showed you in that graph. And so this value 7 is in this interval, right? And so the way that we're going to evaluate this then is going to be the absolute value of the integral of 2x minus 14 dx from 6 to 7 plus the other portion, which would be dx. All right, so we have those two values that we're going to evaluate. And so, of course, we know then that this becomes the following, right? So it becomes the absolute value of x squared minus 14x, and this is going to be from 6 to 7, plus x squared minus 14x from 7 to 10. And so when we do it here, so we're going to do 7 squared minus 14 times 7 minus 6 squared minus 14 times 6, and then we're going to go plus, and then here is going to be 10 squared minus 14 times 10 looked at. Minus 7 squared minus 14 times 7. So this one we want to do together. And so then what we end up with here, once we evaluate everything, let me just do this here. When we evaluate everything is we're just going to get 10. And so you can see that we do it from 6 to 7, the absolute value of that, because since it's below the x, right? This is 7. Since it's below the x and this is 6, this portion right here is below, so we have to, kind of figure that out, and that's obviously going to be negative because it's below the x. So that's why we use the absolute value. All right, the next question that we're going to do is number 35. So number 35, let me write this one here. So number 35 is f of x is equal to x to the third power. And then the interval that they're giving us is from -1 to 3. And so when we do this one, we're going to, everything for this particular value is actually above the x, and so the reason being is that x to the third power is equal to 0 when x is equal to 0. So then this is going to cross the x at 0 in the given interval of -1 to 3. So we're going to do the same thing that we did previously, right? So we're going to find the integral of -1, 0 of x to the third dx plus the integral from 0 to 3 of x to the third power dx. And so that's going to be x to the fourth over 4 from -1 to 0 plus x to the fourth over 4 from 0 to 3. And so when we evaluate this one, right, it's going to be -1 to the fourth power over 4 minus 0 to the fourth power over 4. And then we're going to add this to the other integral, which is going to be 3 to the fourth over 4 minus 0 to the fourth over 4. And so when we evaluate these, we're going to end up with basically here, for the first one, it's going to be 1/4. Because 0 to the fourth power is 0, so that's going to be 0. -1 to the fourth power is 1. 1 over 4 is 4. And then, of course, on this side here, that's going to be 0. And then this is going to be 3 to the fourth power, which is 81 over 4. So the answer here would be 82 over 4, which is equal to 41. And so that's how you do those problems. Now, if it wouldn't cross the x, we wouldn't have to worry about the absolute value of a portion there. So the next question is number 55. And so for number 55, it says that Carla Harvey Communications is a small company of science writers found that its rate of profit in thousands of dollars after 2 years of operation is given by, so let me go ahead and write 55 here. So it's given by P prime of T is equal to 3T plus 3, and then T squared plus 2T plus 2 raised to the 1/3. And so for part A, what it's asking us to do, it says find the total profit for the first 3 years. So in other words, we're going to find the integral there of this particular function for the first 3 years. And so when we look at it, we're going to find basically just the integral of from 0 to 3 of P prime of T dt. And so what we're going to do here, I'm going to go ahead and rewrite this. So it's going to be this. I'm going to go ahead and do this here so I can just be consistent so you guys can see exactly what it is. And so for this particular one, I'm going to let u equal to t squared plus 2t plus 2, which means that du is equal to 2t plus 2 dt. And so if I were to take out a 3, I'm left with t plus 1, then t squared plus 2t plus 2 raised to the 1/3. And so what happens here is that I know that I need a t plus 1 times 3. And so what I'm going to do here is if I make t equal to 0, then u is going to be equal to 2. If I make t equals to 3, and what I'm doing is just I'm replacing the variable with u, but I also have to change the values. And this is going to be 17, right? I just plug it into the function since u is equal to t squared plus 2t plus 2. I can change my my values, if you will. So of course here du is equal to 2t plus 1 dt, which is going to be 1/2 du is equal to t plus 1 dt, right? If I multiply both sides by 1/2, I get rid of that 2. And so since I need a 3, I can multiply both sides by 3, so it becomes 3/2 du is equal to 3t plus 1 dt, right? Okay, so now here I'm going to go from 2 to 17. Here's my 3/2, and then u to the 1/3 du. And so for this particular one, it's going to be 3/2 u to the 4/3 times 4/3 between 2 and 17. And so this is just going to be equal to 9/8 u to the 4/3 from 2 to 17, which is going to be equal to 9/8 17 to the 4/3 minus 9/8 2 to the 4/3. And then we're going to get 46.341. And so since it's in thousands of dollars, it's going to be $46,341. So let me go back over here real quick to the change. So we said that u is equal to t squared plus 2t plus 2, which means that du is equal to 2t plus 2. But if you remember here, I actually need a 3t plus 1, right? So then I factor out a 2, which will give me this right here, which is my 2 times t plus 1 dt. Multiply both sides by 1/2. And so now I have 1/2 du is equal to t plus 1 dt. But I need a 3, so I multiply both sides by 3, and then this is how I end up here. The next thing is that I don't have to go back and back substitute. I can just go ahead and find out when t is equal to 0, what's the value of u? And I'm looking at this here. So when t is 0, since I'm going from 0 to 3, the value of u is 2. When t is equal to 3, the value of u is 17. And so then my integral, instead of going from 0 to 3, since I switched my variables, it goes from 2 to 17. We would have gotten the same value if we would have done it, not switching the variables. But this one's a little easier to do if you switch up the variables. So that's number 55. And then the next one is number 56. And so number 56 here, let me put it over here. Sorry about that. So 56, it says a worker to a new job would improve his efficiency with time. So it takes him fewer hours to produce an item with each day on the job, up to a certain point. Suppose the rate of change of the number of hours it takes to work in a certain factory to produce the X item is given by h prime of x is equal to 20 minus 2x. So for part A, let me go back. I gotta finish number 55, part B, which I didn't do. So for part B, we're going to do the same thing basically, but in this case, it's telling us that we're going to go from 3 to 4, right? So when t is equal to 3, we know that u is equal to 17. But when t is equal to 4, then u is going to be equal to 26. So then we're going to find out the same integral. So this is going to be 17 to 26, 3 over 2. I do apologize for that. This is going to be 1/3 du, which is going to be equal to 3 over 2 x to the 4/3 over 4/3 from 17 to 26. And so when you do that, you get approximately 37.477, which is $37,477. So that's part B. Again, we're just switching the values and then just go ahead and switching the variable t to the variable u. So the last part, for part C, what we're looking for is what's the limit of p prime of t as x goes to, or t goes into infinity, not x. Let me make sure I got this. Yeah, it's gonna be t. And so basically it's just going to be the limit as t goes to infinity of t3 plus 3 t squared plus 2t plus 2 raised to the 1/3. And then this is just going to be infinity because t gets larger and larger and larger, so that's going to be larger and larger and larger. So the annual profit is slowly increasing without bound. And so that's part C. All right, let's go to 56. And so 56, I already read the instruction. So it's going to be h prime of x is equal to 20 minus 2x. And so it's asking, what is the total number of hours required to produce the first 5 items? And so for part A, is going to be from 0 to 5, right, of 20 minus 2x dx, which is just going to be 20x minus x squared from 0 to 5, which is just going to be the following, right? So 20 times 5 minus 5 squared, right, minus 20 times 0 minus 0 squared, and so that's going to give us 100. So it would take, for the first one, for the second one, it would be, actually, let me switch this up here real quick. So 20 times 5 minus 5 squared minus 20 times 0 minus 0 squared. And so for this particular one, it's going to be 75. So 5 items, 75 hours. And then part B, I kind of did it already. So this one's going to go, what is the total number of hours required to produce the first 10 items? So here we're going to go from 0 to 10. And so it's going to be 20 minus 2x dx, which is 20x minus x squared from 0 to 10. And then this is going to be 20 times 10 minus 10 squared minus basically 0, right? And then this is just going to be 100. So 10 items, 100 hours. And that's the end of 7.4. Thank you.